This is the fourth problem on the two-dimensional motion mock test. Magenta antelope drifts down the mighty Tualatin River. She goes 25 meters downstream in 13 seconds. Now that's just a separate problem. It's going to be separate from our boat crossing river problem. That the boat drifts downstream 25 meters in 13 seconds. Okay, so from that we can get the velocity of the boat. So 25 divided by 13 is 1.923 meters per second. That's the speed of the current, right? Now from there we can just treat this just like a boat crossing river problem. Right, so here's the river. The river is 114 meters wide. Right? And she crosses the river. She points the canoe straight across the river, right? Like this. And she crosses that in 43 seconds. Right? So now we can set up our familiar table. We've got across the river, we've got downstream, right? We've got X and V and T. And that's all we ever have on these guys, right? Okay? The 114 meters is the across distance, right? And the 43 seconds is our time, and that's going to be the time for both of these. Okay? So that's what we have so far. And then the 1.923 that we figured out as the speed of the current, that's going to be this velocity. Hey. It's going all right. Okay, so that's going to be this velocity, and then these problems don't have any acceleration, and so I don't know. Do you guys understand? I'm recording a video. That's all right. Anyway, so there we go. That's going to be the velocity like that. You could wave or something, you know. Well, you can't see you unless you're right in there. Okay, so basically this problem, since they tell us the time, right, we can actually solve this thing independently, but that's what you do. You just throw it in there. I can find this velocity by using V is x over t, right? So it's going to be the 114 divided by 43, 2.651 meters per second, right? And then I can find this x. I can go x is vt. Right, so I can go this times this, so 1.923 times 43. I get 82.689. Okay. And then, so we've answered the first question. What is the speed of the current? Is 1.923. What speed did she paddle the canoe through the water? Well, that's her speed across. Since she's pointed across and she goes 114 meters across in 43 seconds, that's got to be her speed across, right? How far downstream did she go in paddling? Well, here it is, right? The 82.7, there it is, just rounded, right? Okay. How far downstream? And then what is her speed as seen from above as she crosses? Well, of course, as she crosses, you don't see her just going across at 2.651. You see her also going downstream at 1.923, because it's like she's on a sheet of paper. She's moving across it, the paper's moving like that. And the speed is the hypotenuse of this guy, right? So square root of 2.651 squared plus 1.923 squared. Okay, so square root of left parenthesis 2.651 squared plus 1.923 squared, right parenthesis, 3.275 something and change, right? And I put as the answer 3.28 because that's what it would be, right? If you rounded it to three places like that. Okay. Then it says, and here's the, this is the soul-searching question, right? What angle upstream of straight across should she point to go straight across the river? Well, what she's going to do then is she's going to take the 2.651, right, and point it this way, right? 4651. She's going to take that speed that she can paddle and not point it straight across, but point it upstream. She's going to point it upstream such that there's some across component and that there's an upstream component of 1.923. Okay? That's the trick. Okay? Now, to find this angle without finding anything else is, since this is the opposite side and that's the hypotenuse, okay, I'm going to use the arc sine, right? So sine minus 1 of opposite over hypotenuse is the angle, right? And this is a trigonometry thing, right? So the inverse sine of 1.923 divided by 2.651 of 1.923 divided by 2.651 is 46.5 degrees, right? The other way to do it is to find this side here. If this is A and this is B and this is C, right? If A squared equals B squared, or if C squared, let's do this again. If A squared plus B squared equals C squared, then B squared is C squared minus A squared. So B is the square root of that, right? So I can go square root of 2.651 squared minus 1.923 squared. 2.651 squared minus 1.923 squared. Find that other side. It's 1.825. Right, and now I can use inverse tangent. I can go inverse tangent of this divided by this. The same way we always have found angles. But there it is. 46.5, and we get that same angle. Alrighty.